Hello, everyone. My name is Yihan Mao, and this is my Lab 2 report for E542 AWS. This lab is for AWS bring up and queuing. So, in this lab, uh, I mainly do three parts following the tutorial. Uh, the first part is to set up AWS networks. The second part is to set up AWS instances. And after that, uh, I go measure the network with iPerf. So let's start the first part, setting up AWS networks. In the first part, uh, I think there's mainly five parts, uh, five steps to uh, set up AWS networks. The first step, we need to create an account and create a new VPC for this lab. Yeah. The second step is to create four subnets. Uh, this four, and the third part is to set up internet gateway and attach to the corresponding VPC. The fourth step is to set up the route table, and after that, uh, we create our new VPC. See here, and we also need to create three elastic IPs for uh, these instances. We will uh, gonna use these three elastic IPs later. So I'm gonna show these steps in AWS. So here, yeah, the first part is to create a new VPC here, and for example, this VPC is called lab2, this part, and the IPv4 here is 10.0.0.0/16. Yeah, and keep others the same. I've created one here. So the next step is to create subnets in this VPC. So select create subnet and select this VPC here and create lab subnets here, the 10.1.0/24. This, for example, this is the IPv4 CIDR block for subnet 1. Yeah, and we can go create. I've created four subnets here, 1, 2, 3, and 4. Yeah, and the third step is to go to Internet Gateways, create Internet Gateway. This lab is called like this one, and then select create. Yeah, after we create Internet gateways, we select it and select this one, attached to VPC. I've already attached my gateway to my VPC, so this is right here. Yeah, and also we need to set up our route tables here. This one. So create a route table named lab2, route table lab2, and select a VPC, and then create after created, do actions here, edit routes, yeah, and enter this line 0.0.0.0/0, and this is the target for uh, lab 2, yeah, and click this one, save change, so we can select it, yeah, and after we do this, VPC subnets, route tables, and internet gateways. After we uh, have done that configurations, uh, our VPC should have an internet connection. And in the last step in our VPC, we need to collect 3 elastic IPs for my 3 VMs in my EC2 instances. We will use these elastic IPs later. So click here, elastic IPs. Yeah, I've already collected 3. If you don't have, select allocate elastic IP address and allocate. So here's the first question for our lab. How is Amazon able to convert your public IP and reach your private IP on the interface? The answer is we use elastic IP address because it's unique. Since elastic IP address is a reserved public IP address that you can assign to any EC2 instance in a particular region until you choose to release it. So in this case, a unique EIP is on the interface that connects the internet, and you can convert it to private IP on another interface in these two instances. I will show in the topology later in the second part, setting up AWS instances. So after we have done with the first part, setting up AWS networks, we are gonna to setting up AWS instances. Here are some more questions uh, in this part, but I will do the general part in AWS. Yeah. So first, we are gonna launch the VYOS instance and do the configuration. After that, we launch client and the server instances. Client and the server instances are very similar, while the VYOS instances configuration is a little bit different, but generally they are about the same, just a little bit difference. So uh, yeah, and we also have to set up network interfaces. Yeah, yeah, create the topology for these instances so they can connect through internet. So uh, yeah, I'm gonna show in AWS that we have instances here, VYOS, a client and a server. Uh, yeah, to do this, the first part is to select to launch instances. So click here. Yeah. Go to the name here. For example, UIOS 2, and just select image here. Here are three UIOS versions, and I select this one, UIOS 1.3 rolling, because this using this image, I can use a free tier virtual machine, but these two are not free. 1.3.3, these two are not free. So select this one, 1.3 rolling, and then select instance type. We select this one, T2 micro, since it's a free tier, and also we need to create a key pair here. So I've already created one here called lab2. So select this one. If you don't, click create new key pair and enter the key name. Yeah, and just create, and you can get PEM file. No, select this one, PPK, for use with PuTTY. And then we can use PuTTY to connect with it. Yeah, and this one here is much more important. We need to set up our network settings. So for example, uh, we need to edit the network settings. For example, the VYOS virtual machine is in, we put it in lab 2 subnet 1, and we need to add some firewalls here. So the first type is SSH, second type is ICMP, third type is TCP, and the fourth type is UDP. Yeah. We allow all data to pass through, and we need to add a network interface here. So we add here. This one is VIOS Ethernet 0, and we also need to add it here. So we can see the topology here. We put VYOS. This one, the first network interface, we put the first network interface on in subnet 1, and the second network interface in network 2, and we can do similarly to client and the server. However, we put the first first network interface in subnet 1 and put the second interface of client in network 3, and the server here is 2 and 4, and assign them elastic IPs. We will talk about it later. So for example, in this in the VYOS case here, so we need to put second interface here and give the name so we can recognize it. So this configuration, I think 4G is good, and some advanced details. We don't change things here. Yeah, so and then we can launch instance. And yeah, so we can launch the VYOS instance here. Yeah, and do repeat this step for client and also server. But for VYOS, we need to do a little bit more. So select it and do actions. No, not here. So we need to change the network interfaces here. Yeah, we go find UIOS, the the second interface here, and do an action called change source destination check. So if it's enabled first, and we need to not select it because um, this one uh, it's a router. BIOS is a router, and it's not a source, neither a destination. So we don't have to. So we need to change this check. So we can see the VPC topology here. Uh, and we also need another step. We need to uh, allocate, associate the elastic IP addresses with client VIOS servers, so we can connect them from the internet. So using SSH, so we need to go here, elastic IPs, select the one, and associate it to this instance. I don't know, choose network interface. And we need to find out which interface it is. So in this case, the network interface is this one, B9. Yeah, B9. So we need to associate one to the network interface. One, yeah. And also choose the private IP address and allow this elastic IP to be associated. So we can give back the elastic IP after we stop the instances. So this is how I do for the first part, and the second part about setting up AWS networks and instances. So next, after we do that, we can connect them through SSH, and and do more things. Yes. So I'm gonna focus on these questions later because my elastic IPs they reach the free tier limit on my account. So I'm gon I'm not gonna show how I do the third part, but I'm gonna show the answer uh, of the questions is in the second part and the third part. So 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 this question, uh, you would have to change network interface adapter settings of source and destination check to allow traffic to pass over BYOS router. So we need to make these settings to disabled because the setting of source and destination check is to check if the instance is the source or destination of the traffic it sends or receives. If not, the traffic will not be allowed to pass. Since BYOS router here is an NAT instances, it's neither the source or destination where the traffic pass over. So in this case, we should disable the, this check to allow traffic to pass over BYOS router. And also, why SSH goes down if IP is changed on that interface? At that's because SSH uses TCP to connect. If IP is changed on that interface, the connection is also interrupted. SSH uses a file named known host to store the IP and the identity of the remote machine. If IP is changed on that interface, the IP and the identity of the remote machine will not be matched. So there's no way that SSH can connect anymore, and so it will go down. So what can be used in BYOS VM to start DH client in BYOS VM? I use this command to show the DH client in BYOS VM. Yeah. So we go next is to install iPerf 3 on client server VM. So these VMs are not able to connect to internet. So I need to change that because they don't have the correct DNS server. So to correct it, we need to manually assign the DNS server, which is to create and modify the in this one, and then reboot these VMs. And after rebooting these VMs, they can connect the internet. Yeah, and in the last question in part 2, you would also have to do sudo apt update. What does this command do? So this command is to update the package list which packages need upgrading to keep all of the packages up to date. So we're gonna use this one frequently to make sure that we use the latest packages and versions of tools in virtual machines. So the third part is measurement with iPerf. So I'm gonna show my answers here because they have like 8 questions here. Yeah. So first we need to execute iPerf 3 as on server VM and iPerf 3 this command on client VM to test bandwidth of the connection over UDP. So and also TCP. So the max throughput and bandwidth here, I tested. The max UDP bandwidth is about 1.03 Gbps per second with about 10% loss, and the max TCP bandwidth is 0.321 GB per second. So we can see a difference here in measurement between these two readings over the same link. So I think there's some reasons. I list three reasons here. The first one is congestion control. Obviously, TCP has congestion control while UDP does not. The second one is optimization in kernel. TCP is optimized for high-speed transfer while UDP is optimized for low latency transfer. The environment, the background of these two protocols codes of using, they're different. So, the developers who developed uh, the kernel and they they're gonna do optimization on these two protocols, and obviously there's a difference between TCP and UDP. And the third is bookkeeping. TCP does bookkeeping once per stream, while UDP does more bookkeeping for each datagram. So the next is to run this comment here, and this is to add 100 megabit uh, milliseconds on client server VM, and there's some change in readings. The max UDP bandwidth increased to around 8.8 GB per second, but and TCP is decreased to around 10 bytes per second, and they change a lot. The reason for these two protocols is TCP requires acknowledgement for each packet. In this case, high latency makes TCP wait a long time period to transmit the next packet, and the bandwidth become low. However, UDP does not have acknowledgement of packages, so it has an increased bandwidth but high datagram loss. So we can say here UDP is do its best effort but don't care about packet loss. But TCP, when the latency is increased, uh, the bandwidth of TCP will go down and it behaves like much more unstable. Yeah. And the third question is to set this comment and take another measurement. The observation here is UDP bandwidth is around 1.2 Gbps per second and with about 10% loss, and the TCP bandwidth is around 3.22 MB per second. Uh, yeah, so I think uh, from this measurement, UDP has no influence on packet loss because it does not have a congestion control. But TCP has a much lower bandwidth because it has to retransmit the packets that are dropped, and then the bandwidth goes down. It 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 is influenced. Yeah. So this comment here is to set delay with 0 seconds, but with a loss of 10% packets. So we also need to run DMESG WH in background kernel logs. Yeah, to look at the kernel logs. Uh, and we can see here the kernel logs. For example, version 1.3 and burst 9015 is lower than device ETH0 MTU. So, and also after we do this, we need to do this command sudo tc this one to deleting this set configuration to do a next measurement. And the sixth question, this is about yeah. Yeah, actually I do this one later than this one. So uh, in this question, the UDP bandwidth is around 9.3 GBs per second and with about 98% loss. So I think this is the fastest speed I see, but with the highest loss in this measurement. And TCP bandwidth, it is around 11.1 MB per second. This is because the token bucket filter is set to 100 Mbit and the size of the bucket is set to 9015 bytes. So in this case, UDP has a high transmission rate, but most packets are dropped. And the TCP here also have packet drops since the limit is low and yeah, I think the router uh, dropped many packets on its internet faces. Yes, and also we want to do sudo install ETH2 as ETH0 speed 10, but AWS, I think AWS doesn't allow us to do that. Uh, yeah, after we type this command, it shows cannot get current devices settings operation not supported not setting speed. So I think it's just because AWS rule that and preventing us to change. Now, yeah, and in the final question, we need to delete all the above set configuration on interfaces on client, server, VM, and do the same steps on VIOS VM on interface not mapped to the elastic IP. So yeah, so uh, so the summary here, the behaviors of VIOS VM are not the same to the client or the server VM since they have different images. Uh, they are different in kernel. So generally, VIOS VM behaves in a lower speed in 100 ms, but much faster in 0 ms with 10% loss, and also this limit in both UDP and TCP. So I think uh, VIOS is a lighter VM. So its kernel, the kernel of VIOS VM is lighter, so it is optimized for transmitting TCP and UDP packets. So in most cases, It has a general faster speed in dealing with data transmissions, but in some particular cases, it may not behave so strong. But generally, VIOS has stronger uh, packet transmission power to transmit data than than like Ubuntu uh, 20. We load on both uh, client and the server VMs. So yeah, uh, that's it. So in this lab, we set up with AWS networking and instances, and we use these instances to measure the network behaviors using iPerf. So, so this is my Lab 2 report. Thank you for watching.